Hello everybody and welcome back to Elementary Statistics Online at Frederick Community College. In this video, I will talk about problems where we're asked to find n, the sample size, that's needed in order to construct a confidence interval with specified confidence level and margin of error. So let's take a look at the first type of a problem like this, where we're dealing with a population mean. And I want to mention that I think one of the reasons why these problems might be challenging at first is the fact that there is no calculator function that will do these computations for you. So we're used to having all these nice built-in commands that do stuff for us, right? So we have binomial, inverse normal, normal CDF, etc. But in this case, we're not going to have such a command, and that's okay. Once you do a couple of problems, you will see that it's really not that challenging. So let's take a look at a formula here. To determine how large the sample size should be in order to estimate the population mean, we use the following formula. We have Z of alpha over 2, which is associated with your confidence level. We have sigma, divide by E, this whole fraction squared, okay? And what is the general strategy for solving problems of this type? We determine what Z of alpha over 2 is, and many times there will be just standard values very commonly used, such as Z-scores for 90, 95, and 99%, okay? Then we carefully plug numbers into the formula, and if the answer has a decimal part, we round it up. So that is your general strategy for solving problems that ask you to find n. Let's go ahead and take a look at a problem. This example is a problem from your textbook on page 452. And as I'm reading this, I'm going to identify my key elements. Let's see. The population standard deviation for the height of high school basketball players is 3 inches. So right away, I see that I have population standard deviation. If we want to be 95% confident that the sample mean height is within 1 inch of the true population mean height, how many randomly selected students must be surveyed? Okay, so these are my key elements. And let's go ahead and go through them real quick. How many? That's the key phrase that tells me I need to find n. Within 1 inch of the true population mean height, that is my margin of error. 95% confidence level, and I have population standard deviation. I have all elements needed to use the formula for finding n. Okay? So, what does the formula say? We need Z of alpha over 2. This is one of the standard values, right? 95%. The value here is 1.96 times the population standard deviation, that's 3, divide by the margin of error, that's 1, close the parentheses. We need this squared, okay? This is how you would plug this in into your calculator. So you see there is no function that will do this for me, right? Enter, and I get this number right here. 34.5744, okay? Which means the actual answer for my problem will be 35. All right, now that we've done how it's done, here's your quick solution. 95% confidence level means that's our Z of alpha over 2. And now I plug in everything in my formula, round it up to 35. Okay? That's how you would solve a problem like this. Now, what if we're dealing with a different type of data? So this is how you would be solving problems if you have quantitative data, right? You have a mean. Now, what if we're talking about categorical data? So we're dealing with population proportion. So still, no calculator function that will do these computations for us. We still need to manually plug the numbers into the correct formula. In this case, we're going to have technically one formula. There's slightly different versions of this, but it's actually the same formula. And we'll talk about why they differ. So if we know what p hat, the sample proportion is, then we would be using the following. P hat times 1 minus p hat, which is, I think in our textbook they use Q for this, times z of alpha over 2 divided by e squared. So if you take a look at this formula carefully, it's kind of similar to the one with population mean, right? So you still have your z of alpha over 2 and margin of error on the bottom, and you square this whole thing, okay? The only difference is that now you have these numbers on the outside, right? So when p hat is given to us, this is the formula that you will use. If p hat is unknown, you use 0.25. And why is that? If p hat is unknown, just assume it's 50-50 chance. So assume that p hat is 0.5. And then look what happens if I do 0.5 times 1 minus 0.5. I get 0.25. That's where that number comes from. So it's not actually made up. We just make an assumption that if we don't know the population, if we're not given a sample proportion, then our sample proportion will be 0.5. Okay? So now that you know your formulas, let's take a look at a problem. General strategy, same as before. Determine what your z of alpha over 2 is. Plug in numbers into the right formula. Round your answer up. Okay? Let's see. Suppose an internet marketing company wants to determine the current percentage of customers who click on ads on their smartphones. How many customers should the company survey in order to be 90% confident that the estimated proportion is within 5% of the true population proportion of customers who click on ads on their smartphones? Okay, so let's see, what do I have here? How many customers? Okay, I have 90% confidence level within 5 percentage points. There is a word missing here, but that's all right. Of the true population proportion of customers who click on ads on their smartphones. Okay, how many? That tells me that I'm going to be using one of the formulas from the previous slide. 90% confidence level. So z of alpha over 2 is known. It's 1.645. And then 5%, that's your margin of error. So I don't have p hat, which means my p hat is 1/2. So that means my number here is 0.25. Okay, now I'm going to do 1.645. That's my z of alpha over 2. Divide by, what's going to happen here, I need to convert the margin of error into decimal, so 0.05. That's very important. And this quantity needs to be squared. Okay, so I get this number right here, 270.6025, which means my actual number, my actual answer will be 271 customers that need to be surveyed. Okay, so here's your solution. The 90% confidence level, that means we have this z of alpha over 2. Since p hat is not given, we assume it's 1/2. Make sure to convert the margin of error into decimal. That is very important. Okay, let's say you have 15%, you would be putting 0.15. If you have 3%, you would be putting in 0.03 and so forth. So the company needs to survey at least 271 customers. We always round up, no matter what the decimal place is. Okay, decimal part. All right, so that is your solution for this type of problem. Okay, let's say we were given p hat. Let's say p hat was given and it was 0.22. Then instead of using this formula, you would be using this formula. Okay, so you would say 0.22 times 1 minus 0.22, this part would be exactly the same. Okay? And just to remind you real quick that these are your most commonly used levels. Okay? 90, 95, and 99%. And the Z's that are associated with each level are also listed here. At some point, you'll probably just remember them because that's how often they're used in a statistics course. Okay? Or if you don't want to memorize them, you can always put them on your formula sheet. All right, I hope this was helpful. So practice these problems. If you have any questions, definitely reach out to me and we'll do really good on this topic. All right, thank you for watching.